In question 3, we're asked to sketch a velocity time graph, okay? And what's important when you do sketch one, your axes, of course, you need to use a ruler here. Don't forget to label the origin, and don't forget then to put the axes labels in place, velocity and vertical axes, and the units, right? So important, meters per second, and time then measured in seconds, okay, on the horizontal axis. Now it says in this question that a train starts from rest, okay? In other words, it starts from speed 0. Okay, so this is our starting point here. And it says then that it goes on a horizontal track towards station B. So the first stage of its journey, it accelerates, okay? It accelerates at a constant rate for 60 seconds until it reaches a speed of 30 meters per second. So, you know, if it accelerates, we're going to have a positive gradient, okay? So our line's going to look something like this, okay? And that's going to be for 60 seconds. Yeah, until it gets to a speed of, what's the speed going to be? It says 30 meters per second. Now, what I like to do is do broken line here to show that's the speed it reaches to. And that will be in a time of, as the question states, 60 seconds. So a broken line essentially just takes us to the values on the axes, but it doesn't form part of the actual graph then, right? So broken line's okay. Just don't do a straight through line there, okay? Because the graph is going to be marked on what you have here, okay, with a straight line. So that's taking us to a speed of 30 meters per second in 60 seconds, okay? And it gets to point X. The train then, it says, continues at 30 meters per second to a point Y, okay? So it continues at that speed. So in other words, we've got a flat line then, yeah? Okay. Flat line then, until it reaches a point Y when a constant deceleration is applied for 40 seconds. So the speed of the train as it passes station B is 15 meters per second. So basically now it's going to slow down to 15 meters per second. Okay, so what I can do now is apply that deceleration. Sometimes it's good to draw in the dotted line first, okay, so that we can see where to connect this to. Okay, so deceleration, of course, means a negative gradient. So you can see my line going down that way. And then it reduces its speed to 15 meters per second until it passes through station B. So that's it. Okay, our graph is essentially done there. Okay, we don't know how long it goes at a constant speed for. It doesn't say, right? So we're going to have to call that distance, say distance t, alright? So that means then we're going to have 60 plus t here, yeah? But we do know that it applies the deceleration for 40 seconds, doesn't it? When it gets to point Y, okay? We can note that there if you want. When it gets to point Y, it's going to be 40 seconds slowing down until it gets through station B. So if I add 40 onto that, that's going to be 100 plus t. Okay, so there's my velocity time graph there. Part A is done. Okay, so part B then, it says find the acceleration of the train and the distance travelled by the train was acceleration. Okay, so for the acceleration, remember the acceleration, quite simply, is the gradient. Okay, is the gradient, how steep this is. And you can do that then by getting the change in velocity divided by the change in time. Okay, so if we look at the change in velocity, well, it goes from 0 to 30, doesn't it? Okay, so the change in velocity is 30 over a time of 60 seconds. Okay, so there's my triangle there, if you like. I don't need to draw it in. So I've got the change in velocity, which is the rise there, which is 30, divided by the step then, which is 60. So you get then 0.5 meters per second squared. Okay, you could use V equals U plus AT as well, it will come out. So we've answered that, and then it says the distance travelled while the train is accelerating. So remember, the distance travelled on the velocity time graph is the area. Okay, the area under the graph. Right, so the area under the graph will be the area of this triangle. Okay, so the triangle will be, well, remember the formula for a triangle is base times height divided by 2. So the base is 60, the height is 30, divide by 2, you get 900 meters. Okay, so that's the distance that's travelled there. Okay, so then part C then, it says find the total time for the train to travel from A to B. Well, we obviously need to work out T for this, yeah? Okay, that's the sort of the main thing here. We've got to work out T in order to determine the total time travelled. Okay, so it'll be 100 m plus T. Now, what we can do is appreciate the other information they've given us, that the distance between A and B, stations A and B, is 24 kilometres. Okay, which of course is 24,000 metres. So if we could sort of work out the area on our velocity time graph here, the total area, then we can put it equal to 24,000 and then somehow work out T. Now we know the area of this is 900. Okay, the area of this, well, it's a rectangle, isn't it? So it's a rectangle with width of T and the height of it is 30. So the area there will be 30 times T. So just see it as a rectangle, and we've got that there. Now, this is a bit different, isn't it? Because well, you could split it if you want into a triangle and a rectangle. It's better to see it as a trapezium. Okay, so if you turn it on its side, you can see then the trapezium there, yeah? Okay, so if we work out the area of the trapezium, okay, so we call that, we'll write that down there. We'll put our formula, so remember our trapezium is that formula there. So it'll be half. Now A is that side there, yeah, which one of the parallel sides, and it's parallel to this side, which is 15 here. Times then the distance between them, okay, the height between them. Now remember that distance there was 40 seconds, wasn't it? Okay, so if I work that out there, okay, I get 900. So all I've got to do then is add up these distances. So I've got 900 here, 30t here, 900 there, and that will equal to 24,000. So then 30t is equal to 24,000 minus 1,800, and I put them together. So then t then will be 22,200 divided by 30. Okay, so if I get that out of my calculator, it comes out to be 740. So the total time then will be the 740 plus then the 100. So I get 840 seconds. Okay.